Welcome to third lecture on soil water concepts. This particular lecture is important from irrigation point of view, and particularly while selecting particular type of emission device, we are required to know how does the hydraulics of soil water takes place when we are applying water through micro irrigation drippers. In this particular lecture, we will deal with soil, its different properties, types of soil, how soil water they are related, how the soil water concepts has been used, and then different forces affecting soil water movement. When we talk of soil, so soil is mixture of minerals, organic matter, gases, liquid and myriad of organisms that support plant life. There are several horizontal layers, and these layers are known as horizons. They are rich in organic matter and then followed by rock layers. Any soil, it consists of a solid material, it consists of pores, and these pores will have air or partly filled with water or fully filled with the water. Now, when we look different types of soils which are in our country, so different soil groups have been classified based on the color or disintegration of the basic parent rock material. If we look to the pie diagram, what we see that red soil dominates in the country, and it is covering about 105 million hectare land area, which is about 34%. Then next in the order is black soil, alluvial soil, then this your desert soil, hills and the tarai soil and alluvial soil. So, there are these soils are distributed. If you look at the right side of our Indian map, and you may see that the large part of the area with this red color which we are seeing, it is being covered in this group. So, this area basically you may see that the red soil dominating area. Next in the order is the black soil, and then other soil they are. So, they are distributed in different parts of the country, and they have got different water retention property, they have got different water drainable property, water drainage property, they have got different properties. So, accordingly irrigation water is to be supplied through micro irrigation drip emitters, or even conventional irrigation system also. These soil groups, their water holding capacity, they play important role. Now, when we look at black soil regions, so these black soil regions are basically dominating in the Deccan Plateau, and the Deccan Plateau area, it is it is located in Maharashtra, Gujarat, Madhya Pradesh, Karnataka, Andhra Pradesh, Telangana, as well as in Tamil Nadu. Why this black soil it has formed? It is the compounds of iron and aluminum. These soils are low in nitrogen, zinc, organic carbon, and they are rich in manganese as well as calcium. They have got typical properties. When it comes in contact with the water, it swells, but when there is a deficiency in moisture content, when soil dries, the cracking problem comes. So, they are actually a problem, and particularly with drip irrigation, it is highly suitable rather than giving water or conveying water through the irrigation channel also, it is a great problem. Now, the major dominating crop in these soil regions are cereal crops, oilseed crop, citrus and fruit crops, citrus, fruits and vegetable crops, which are when we look at these crops, you can see citrus, fruits, vegetable, sugarcane, they are highly suitable to drip irrigation system. Alluvial soils is another group which are formed due to deposition of the rocks material due to the wave, this overland flow from the river areas, and then it gets deposited. So, these regions are available from Punjab, means all the northern part of the country where there several rivers are flowing, they are dominated by alluvial soil regions, and majority of the cereal crops as well as vegetable crops are being grown in alluvial soil regions. Red soil regions, as I told you that this is red soil regions are dominating in the states like Tamil Nadu, Karnataka, Andhra Pradesh, and these soils, if you see, this is this is formed due to decomposition of crystalline rocks, and granites or gneisses are from the rocks. So, they have formed, and these soils are rich in minerals and as well as iron, potassium, manganese, but they are having they are deficient in nitrogen, humus as well as in phosphorus. Rice, millets, tobacco and vegetable crops are being grown. The laterite soil, this is formed due to the high temperature. So, weathering of rocks as well as heavy rainfall takes place due to these climatic variations, and that is causing the formation of laterite soil. These soils are rich in iron and aluminum, but as such these soils have got acidic in nature, and these soils are suitable for cultivation of tea crop, coffee, rubber, and then many other crops which are suitable to grow, apply micro irrigation system, sprinkler irrigation system, and you may find that these crops are being irrigated in different regions. Arid and desert soils. Arid and desert soils, it is found in the arid and semi-arid regions where the annual rainfall is less than 500 millimeter, and large part of Rajasthan, Punjab, Kandi area, Punjab, Haryana, there you will find that arid regions are available, and then the in the presence of phosphate and nitrates, the availability of soil moisture means irrigation, such soils are it becomes fertile, and there are several examples. It shows when irrigation is being given, it was all desert in the Rajasthan area due to application of Indira Gandhi Canal Command, those areas have become green. So, forest and mountain soils, the name it says that these regions are falling in the your hilly slopes, and they are brown, such soils are brown in color, and coffee, tea and tropical fruits are being grown, and once we analyze their physical properties, chemical properties, accordingly irrigation water as well as certain amendments in the soil can be made, and then it can be made productive. Peaty soils and marshy soils, as the name says, means water stagnate for longer period. They are these soils are not having adequate soil porosity, means soil air. So, the cultivation of crop, it becomes difficult, and say particularly peaty soils, they are the deficient of copper. And then marshy soil, most of these soils are available in Bihar, coastal parts of Odisha, Tamil Nadu, West Bengal and Uttar Pradesh, and they are deficient. So, accordingly the soil amendment is to be done when we want to bring these soils for cultivation. Saline and alkaline soil, these are the also problematic soils, and these are available in the arid and semi-arid regions of the country, and they are to be if they are to be brought under cultivation, then we need to apply sufficient amount of gypsum or calcium treatment, so as to bring it. Otherwise, these soils are not suitable for cultivation. So, those are the different types of soil according to the their physical properties, chemical property, their treatment is to be done, and these are to be brought for cultivation of a specific crop and using appropriate irrigation system. Now, the next part, when the soil comes in contact with the water, how does it behave? And then any soil material, if you take it, it consists of it consists of mineral, it consists of organic matter, and then in between the soil particles there are pore spaces. There are pore spaces. In these pore spaces, water is available as well as air is available. So, and in these pore spaces, depending on the way the soil composition it exists and their porosity it exists, the soil the root proliferation it takes place. And so, proper understanding of soil and soil water is important for the plant to growth, and which is very important for efficient irrigation system. When when we say about the soil water, so a very important component is involved, soil texture. Soil texture means relative proportion of sand, silt and clay in a given soil. So, when if you see sand when you are putting water or even without water, you feel like a coarse grains and there as well as gritty. When you see at the clay, these are the finer particles, this having part, and when it comes in contact with water, it looks it is sticky. And then silt, you feel silky, smooth when it is brought to the in contact with the water when we apply water. And when they are in different proportions, means loam, when I say it is the combination of sand, clay, silt in different proportion, accordingly the nomenclature is being given, whether it is a sandy clay loam, whether it is sandy loam, whether it is a silt clay loam. So, different proportions it makes that type. So, this is the diagram, this is the triangular diagram which actually gives the grouping that which category a particular soil it belongs. Just now when I was telling you the different proportions. So, you can see here, suppose let us say it is a sandy soil. So, in a sandy soil, this side of this triangle, it is showing the percentage your clay, this is showing percentage sand, this particular side is shows the percentage silt. And if you take a particular triangle, let us say this particular triangle. So, this is a sandy soil where 90% it is sand and 10% clay. but when all three are putting it, so different triangles you can see it forms a different. So, their nomenclature it has been made based on their proportion it is there. Now, when we say clay, silt or sand, they are classified based on the size of the particles available. So, when we say clay means it is less, the size of the soil particle is less than 0.002 millimeter. When I say silt, so silt means the soil particles are in the range of 0.05 to 0.10. Now, sand could be of different grade. It can be very fine sand, it can be fine sand, it can be very medium sand, or it can be very coarse sand. Means the particle sizes which is say 1 millimeter to 2 millimeter means it is a very coarse sand. So, accordingly their grouping has been made. Now, after knowing the soil texture, how these soil particles they are arranged, means sand, silt, clay, they are arranged, how they are, it has been made a soil aggregate. So, individual soil particle it looks like this. Of course, this it looks here a bigger size, but it could be as small as less than 0.002 millimeter. Now, when these soils are forming together, it becomes soil aggregate. Now, when it is soil aggregate, how they are making how they are making the different structure. So, you can see here this is right side, this is a means your granular structure, this is a platy structure, this is wedge structure. So, how these soil particles they are arranged each other. It can be a blocky structure, it can be prismatic structure, it can be columnar structure. So, depending on the arrangement of these particles they make it, and the root growth, root penetration, proliferation will depend on the type of soil particle, how they are arranged each other. Now, if we look at in this diagram, if it is a sandy soil and water is being given say from the top, you are either it is a irrigation water, whether it is a rainfall water, you are putting it. So, what happened, since it is a sandy soil, particle size is large, the micropores are also large. So, water becomes easy and then it start draining very fast. In sandy loam soil, particle sizes are small and then it is a moderate, means drainage of water from the soil column. When it is a sandy loam soil, it will be lesser than the sandy soil. When it is a clay soil, what happened, the particle sizes are small, the pore sizes are also small, means it consists of a fine pores. So, the movement of water is slow, very slow, and depending on the particular type of this thing. Now, I was telling you any soil system, it consists of the grain, it consists of the pores. Now, if it is a grain means it is a solid, and when we take it as a 1 cubic meter volume of a soil column. Now, in proportion wise if we are making it, so some part of the proportion volume it is having solid, some part it will have the pore space. So, we can say the 1 cubic volume of the soil column, it has some a space where the pores are there and some has got solid particles. This can be expressed in terms of the mass of air, this can be expressed say. So, this pore space consists of air, it can consist of water. So, that depends how much pore space, whether it is completely fully dry soil, there is no moisture content. So, it is only entire volume of the pore volume is full of air. So, it will be say V A plus V W is simply V V, that is the volume of void, total volume of void. So, we can say if it consists of air, water and solid. So, the one part we are putting mass of air, another one we are telling mass of the water, mass of the solid particles, and when we are summing together it becomes total mass of the soil particles or soil column, and this can be expressed by volume of air, volume of water, volume of solid. So, these volumes as well as mass, it can be expressed with certain terminologies which are important when we are giving water. So, one important parameter, it is known as a particle density or true density. What is particle density? It is given by mass of solid divided by volume of solid. Okay. When I was putting you 3 points, that is volume of solid, volume of air, volume of water. So, this is the volume of solid, and then dry bulk density, it is the mass of solid divided by volume of total volume. So, total volume is nothing but volume of solid plus volume of air plus volume of water. Now, this the dry bulk density values for the different soil textures. Just now I told you about sandy soil, loamy soil. So, for different soil texture you may see that these values are available, So, these are used for several structural design, for irrigation purpose when we want to do, or for different purposes the value of bulk density as well as particle density is being used. Now, total bulk density, when we say total mass, so mass of solid plus mass of air plus mass of water, this is referred as a total mass, and V T is the volume of total volume. And then other terms depending on the void space means air and water. So, total void this is expressed as the porosity. So, porosity is basically volume of void divided by total volume. So, volume of void means volume of air plus volume of water. So, this is your total porosity. Now, this can be expressed also in terms of bulk density and true density units. So, this can be given by 1 minus rho b by rho s. So, this that can be calculated. Soil water content, someone wants to know how much is the soil water, means how much amount of water present in the soil. This is measured in terms of gravimetric water content, mass water content or soil water content. Soil samples is collected by using the soil core, and then the sample is brought in the laboratory. We weigh the sample along with the water, because the sample has got dry soil plus water, and then we are weighing it and then drying the soil sample at 105 degree Celsius for 24 hours in a oven we keep, and then we find out the dry sample and then determine the amount of water available in the soil, that is mass of water divided by mass of solid. We can express these values in terms of volumetric unit. Volumetric units means volume of water present in the soil sample. So, this can be given by volume of water in a total the volume of soil. So, which can be also expressed in terms of soil moisture content. So, theta v can be given by in terms of volumetric water content. So, volumetric form of water content. So, moisture content by weight you have got, and then you are multiplying with this ratio, that is a bulk density divided by bulk density of water, bulk density of the soil divided by bulk density of water, and this density of water we consider it as 1 gram per cc. And if we want to express what is the depth of water in the soil layer. So, this volumetric water content which is there, if we multiply it by the depth of soil sample we have considered. So, this one can get what is the equivalent depth of water available in the soil. Now, we come across different types of soil water in the literature, and which are got some certain physical meaning. If we look, suppose it is a saturated soil column, when we are allowing the water to flow by gravity, and the soil sample from the column, it is coming out of freely under the influence of gravity. This water is known as a gravitational water, and from the potential point of view, this particular potential, it is 0 for the saturated water, and when it brings to the field capacity, it is up to 0.33 bar. So, we say 0.0 the gravitational water is available at 0 potential or 0 metric potential or 0 to 0.33 bar. And when the another category of water is a capillary water, from the potential point of view, it is from 0.33 bar to 31 bar. And then hygroscopic water, this is a very a specific condition when the soil is dry, and then the soil sample is exposed to the water vapor, then because of the force of adhesion, the soil particles are attracting the soil water molecules, and then this water is that is called a hygroscopic water. So, which is explained like this, this is the when the soil means there is micropores, and when it is a gravitational water is flowing freely from these pores. When it comes to the capillary water, this is the water which is available. This water is not available from the irrigation point of view. Capillary water is the only water which is available for irrigation point of view, and this capillary water basically what happen when suppose there is a water table, and then on the top there is a sandy soil. So, because of the capillary forces, water start rising up. So, the pore sizes are larger. So, the movement of water up is lesser, and in case of clay soil, the pore sizes is smaller. So, the water is rises. So, plant takes water for meeting its evapotranspiration requirement, but that is a capillary water, and this water hygroscopic water, it is from irrigation point of view, it has no meaning, because this water is not available as such for plant to give irrigation. There are some forces, this is a very important part. When I have told you that one part is your gravitation, it is the water held tightly to the surface of soil surface and absorptive forces. So, there are forces which are acting, and that is being captured by the soil particles. So, adhesive forces and as well as cohesive forces, they are responsible for holding the water, that is the capillary water. And now, the water when it takes place movement from the soil to the plant root system. If it is a normal clear water without any salinity, the movement of water is not turgid when sufficient water is taking place. But if the water or soil has got salinity, because of the salinity in the water, the movement of water is slow. Now, the water which takes place from the higher concentration to the lower concentration, this process is known as osmosis. So, osmotic effect takes place. So, here the adhesive forces and then cohesive forces as well as osmotic forces are important when irrigation water or water movement from the soil to the plant system takes place. Now, so gentlemen, participants, we have discussed in the lecture what is the soil, what are the different types of soils, and then what are the different textural part of the soil, how the soil aggregate it form, that is the soil structure part, soil properties in relation to irrigation water application. So, soil texture, soil structure, soil water quality, and forces in relation to soil water movement that we have discussed in this lecture. Now, forthcoming lecture we will discuss about soil water constant and soil water movement. These are the books which one can refer in this particular lecture. Thank you very much.